In this video, we are going to see about the equivalence of NFA to the DFA. So here, the theorem is if a language L is accepted by the non-deterministic finite automaton with the epsilon transition, then there exists a deterministic finite automaton that accepts the L. So these are the steps for doing the conversion. First, we have to take the epsilon closure for the beginning state of NFA as the beginning state of DFA. So then we have to find the state that can be traversed from the present for each input. That is union of transition value and their closure of each transition of NFA present in the current state of the DFA. Then whenever we are finding the new state, we have to take that as a current state and we have to repeat the step 2. And then we have to repeat the step 2 and 3 until no new state present in the DFA. Then we have to mark the state of DFA which contains the final state of DFA as the final state of NFA as the final state of DFA. We will see one example. So here we are going to convert the epsilon NFA to the DFA. So first step, we need to find the epsilon closure for all the state. So step 1 here is find epsilon closure for all states. Epsilon closure for all states. So epsilon closure of A is equal to A, B and C. So that is from A, first we have to write the same state. Okay, then we have to check whether there is a transition from the state A. So from the state A there is a epsilon transition to the B. So B, then we have to check from A to B, B to C also there is a transition, epsilon transition. So C also. Then epsilon closure of B. So what is the epsilon closure of B? We have to write the same state B. Then we have to check from B there is a epsilon transition. So there is a epsilon transition to the C. So BC. Then epsilon closure of C. Epsilon closure of C. So first we have to write the same state. Then we have to check whether there is a epsilon transition. There is no transition. So only the C. Then step 2. Epsilon closure of the initial state of the NFA is the new initial state of the DFA. So here what is the initial state? A is the initial state. So A is the initial state. Okay. So we have to check what is the epsilon closure of the initial state A. So initial state, epsilon closure of the initial state is ABC. So what we are going to do? We are going to take that as a initial state. So epsilon closure of A is equal to A, B and C. So it is considered as a initial state and I am giving new name as a Q0. So this is the initial state here. From this new state Q0, we have to find the transition for the input 0 and 1. If we get the new state from the new state, we have to find the next transitions. Okay. So next we will find the transition of the DFA. So let delta dash be the transition function of the DFA. So delta dash of new state we have taken as a Q0 and input symbol is 0. Here two input symbols 0 and 1. So input symbol is 0. We can write this as epsilon closure of delta of Q0 comma 0. Okay. So what is a Q0? ABC. So we can expand this epsilon closure of delta of A, B, C, comma 0. So what is the transition from ABC to 0? For ABC to 0 is BC and C. So we can write epsilon closure of B comma C. Then next we have to find the epsilon closure B and C separately, and we have to take the union. So that is epsilon closure of B union epsilon closure of C. So what is epsilon closure for the B? It is BC. So it is B comma C. Then what is C? For C also 0. So when you are taking the union, it is B comma C. So this is the new state. So we can give the name as a Q1 here. The next we have to find for the input symbol 1. So delta dash of Q0 comma 1. This is equal to, same thing we have to write, epsilon closure of delta of Q0 comma 1. So we can write this epsilon closure of delta of Q0 is A, B and C comma 1. So what is the transition from A, B, C comma 1? It is A, B and C. So epsilon closure of A comma B comma C. So when you are taking the union, so epsilon closure is A, B, C. So this state is already available. It is a Q0 here. So now we got the new state BC, right? So we have to calculate the delta dash for BC. So we have given the new name as a Q1. So we can write this delta dash of Q1 comma 0. It is equal to epsilon closure of delta of Q1 comma 0. So what is Q1? We are expanding that closure of delta of. So what is Q1? Q1 is BC. So B comma C then comma 0. So we have to check the transition for B comma 0. So for B it is null, for C it is C. So epsilon closure of C. So what is epsilon closure of C? It is a C. So now we got the new state. So we are giving the name as a Q2 here. The next delta dash of, for the input symbol 1 we have to calculate, Q1 comma 1. It is equal to epsilon closure of Q1 comma 1. Sorry, delta of Q1 comma 1. So here we can write epsilon closure of delta of B comma C comma 1 here, 1. So what is transition for B comma C comma 1? It is B and C. So it is epsilon closure of B comma C. So what is epsilon closure of B comma C? It is B comma C. So already we got this and we have given the name as a Q1. So it is Q1. Now we got the new state as a Q2. So now we have to find the delta dash for the Q2. So delta dash of Q2 comma 0. It is equal to epsilon closure of delta dash of Q2 comma 0. It is equal to epsilon closure of delta of, what is Q2? It is C. C comma 0. What is C comma 0? It is C. So epsilon closure of C. Epsilon closure of C is also C. So already we got this new state. It is a Q2. Then we have to do for the input symbol 1. So Q2 comma 1. So same thing we have to write epsilon closure of delta of Q2 comma 1 is equal to epsilon closure of delta of C comma 1. So what is delta of C comma 1? It is C. So epsilon closure of C. So epsilon closure of C is see, it is already available. It is a Q2. So now next what we have to do, we have to write the transition table and the diagram for this. So we will draw the table here. So input symbol is 0 and 1. Input symbol is 0 and 1. And the states are 3 states we got, Q0, Q1 and Q2. So what is Q0 comma 0 and Q0 comma 1? Q0 comma 0 is Q1, then Q0 comma 1 is Q0. Right. So here it is Q1 and Q0. Next we have to check for the Q1. Q1 comma 0 is Q2, Q1 comma 1 is Q1. It is Q2, Q1. Then Q2 comma 0 is Q2 and Q2 comma 1 is also Q2. It is Q2 and this is also Q2. Now we can draw the transition diagram. So Q0. Okay. So here we have to confirm with the final state and the initial state. So here what is the initial state? In a NFA the initial state is A. So Q0, A where the A is available, in a Q0 there is a A. So it is the initial state. So there is no change. Q0 is the initial state. Okay. Then we have to check the final state. So what is the final state? C. So wherever C is available, that is the final state. So if we check the Q0, here C is available. Sorry, Q0 is C is available. So Q0 is also final state. Then for the Q1 also C is available. So Q1 is also final state. And for Q2 also C is available. So Q2 is also final state. So Q0 is final state. Okay, from Q0 to Q1 there is a transition. This is final state. Q1 there is a transition for the input symbol 1. Then from Q0 to 1, so it is in a Q0 itself. So it is 1. Then from Q1 comma 0, it is Q2. Q2 is 0. Then Q1 comma 1, it is Q1. It is 1. The next one Q2 comma 0, it is Q2 itself, so it is 0. Then Q2 comma is also Q2, so it is 1. So this is a transition diagram and this is the steps to convert the epsilon NFA to the DFA.